how much we have learned in the coordinate geometry. First, we saw straight lines. So to draw a straight line, we used two things. One was slope and other was a point. Right? So to draw a straight line, we need to know two things. One is slope and second is a point. To draw a circle, we use two things. First was radius and second is obviously a point. We always need a point to draw any of the conic or any of the straight line or circle. So to draw a circle, we use a radius and a point. Now in case of parabola, we'll use a line and a point. So in case of parabola, we use a line and a point. And this line is called as directrix and the point is called the focus. So in case of a parabola, we need two things to draw a parabola. The first one is a point, a fixed point, which is called the focus, and the second thing is a line, which is known as the directrix. Right? So first we'll see what is the shape of a parabola. How does a parabola look like? It looked like something like this. So this is a standard shape of a parabola. Now what is the definition of parabola? Parabola is a locus of a point. Locus of a point whose distance from a fixed point is equal to the distance from a fixed line. So you need to understand this definition very nicely. A parabola is a locus of a point whose distance from the fixed point is equal to the distance from the fixed line. Now this fixed point is always called the focus and the fixed line is always called the directrix of a parabola. Right? So now we'll see how do we obtain this locus. So let's assume that this is a fixed point, focus, denoted by S, and this is our fixed line. So the parabola is the locus of a point which is equidistant from a fixed point and the fixed line. So we need to see the locus of a point such that its distance from this line is equal to the distance from this point. So let's say this is M and this point is P. So we need to know that PS is always equal to PM. So I have to see all the points whose distance from this point and this line are same. So the next point will be somewhere over here. So this will be the distance and this will be the distance from the line. Similarly here and here, and when this line will be perpendicular, it will come in the midpoint. Right? So this thing will be the midpoint of the line joining this point and the focus. So the parabola will look something like this. Right? So that's how we obtain a parabola. We just need a fixed point and we need a fixed line. Now guys, see, there's one major confusion which happens to everyone, that we say, some people say that the definition of parabola is the point, the locus of a point which is at a constant distance from fixed point and a fixed line. Now you cannot use the term constant distance because this distance over here, it's not constant. First this distance was greater and then it was becoming smaller. Okay? But the thing is that the distance between these points, the focus and this given point and the line, these distances are equal. This distance is not constant like in the case of circle, but the distances, these two distances are equal. So we can see that SP is always equal to PM in case of a parabola. Right? So this is a basic definition of a parabola. So guys, how many points will satisfy this condition? How many points will satisfy the condition that the distance from this point and this line are same? There will be an